this yesterday, like up to Fibonacci series, right? Today we'll try to complete Armstrong, palindrome, all this, and then we talk about nested loops using while, and then we talk about for um, how much ever we can discuss today. We try to discuss that much in today's session. Okay. So another important logics here, Armstrong and palindrome, and then nested loops. We'll try to have a quick idea about all this one by one. Okay. So now I'm sharing my screen. I think screen is visible, right? So what is this Armstrong, friends? You need to understand Armstrong thing here, okay? Armstrong means the logic is something, a sum of cubes of digits of a number. Suppose you take some 153. This is an Armstrong number. We have to find one cube up, okay, plus 5 cube, okay, 5 to the power of 3 plus 3 cube. Okay. So this is Armstrong number. So now you try to do the sum of all these numbers. 1 cube is 1 only plus 5 cube means what is that? 125, I hope. Right? 5 5 is 25, 25 5 is 125. 3 cube means 3 3 is 9 and 3 is 27. So this is what it is. So if you add all this, you will get this 153 back again. Now again, if you add all these numbers, you get 153. And here, one more important thing is this is a 3-digit number. So you will find cubes. So sum of cubes of digits of a number. Sum of cubes of each digit of each cube of a number is nothing but equal to if it equals to the original number. So, 153, what we did sum of cubes of each digit, 1 cube plus 5 cube plus 3 cube. And when you try to add all these cubes, again, it is giving us 153. And if we get again the same number as output, then or if the result is same number as your input, then that is an Armstrong number. And this is for 3-digit number. Suppose if it is 4-digit number, suppose it is 1, 2, 3, 4, then this time we should not do sum of cubes. We have to do the sum of, uh, we should do that number to the power of 4. If digits are 4, we should do 1 to the power of 4 plus 2 to the power of 4 plus, sorry, 2 to the power of 4 plus 3 to the power of 4 plus array 2 to the power of 4, that is fine. 3 to the power of 4 plus, what is one more thing? 4 to the power of 4. So here we have to do the digit to the power of 4 if the number of digits are 4 digits. Suppose if I have 5 digits, 1, 2, 3, 4, 5, then what is that I should do? I have to do to the power of 5, digit to the power of 5. Sorry, that is 1 to the power of 5 plus 2 to the power of 5. So plus dot till that 5 to the power of 5. This is Armstrong. You got it right. If you take a number and if we have to see how many digits are there in that. Suppose if you want to be more clear, just a minute, somebody pinging me. Okay. I think you got the logic, right? Also, you can Google check once. Best thing is do one thing, Google check Armstrong to be very clear. So many people have idea about sum of cubes of digits and to the power of 4 to the power of 5. Most of the people don't have that that idea. So, but actually, this is how Armstrong number is. Remember, okay? So you can see if this guy is clearly mentions that it's fine. Okay. See, a positive integer of n digits is called this one. Okay. If it is 153, it has to be like this. And 1, 2, 3, 5, 1, 2, 5, 3 is not Armstrong. He is still doing cubes. We should see, you can see here. Here, this guy, what he does is he did to the power of 4, you can see 1 into 1 into 1. If digits are four digits, you can see what this guy is doing. You can see here. He is doing to the power of 4 here. 1 into the power of 4, 2 into the power of 4, 5 into the power of 4, 3 into the power of 4. Generally, power of 4 means generally we create it like this, right? That's how we create. This is one thing. Also, actually, even so, even if it is power of 5, we have to give it to the power of 5. So if we have 5 digits, we should find individual digit to the power of 5, and we have to sum all those digits where we do the power of 5 here. So many examples only talk about 3 digits. Okay. But actually, this is the logic, friends. I am just trying to make sure you understand it perfectly. Okay. But anyhow, you got it right. Let's not waste much of our time. Let's jump into the programming part. Okay. Are you okay with this? This is Armstrong number. This is how you have to create Armstrong numbers. Okay. Do you understand the problem, right? First, understanding problem is important. Later on, you can create solution. Okay. Now, let us start with working with three-digited number. Maybe if you want, I will show you how to work with four-digited as well, or else five-digited. But one thing, based on dynamically, you should be able to do this. What is that? So one important thing in programming is if you have to see first how many digited number is this? Is it three digited, four digited, five digited? And based on that, you have to implement your logic. Okay. So finding length of that number is very important first. What is the important thing you should do? Length. Length means how many digits are there in that number. And based on that, you should apply that power. That power should be, if it is three digits, we have to do that number to the power of number to the power of that total digits. Like if we have three digits, we should say we should create 1 to the power of 3 plus 5 to the power of 3 plus 3 to the power of 3. It's not just 153. Any three digit, you have to do the cubes. Any four digit, you have to do the power of 4. Any five digit, you have to do the power of 5. Any six digit, you have to do the power of 6, something like that. Is that clear now? Sorry, I think I took some time to clearly give you a picture of Armstrong. Okay. But you got it right now, right? Now let us create a program on this. Because there is a little confusion for people here. What is Armstrong to understand that? That's why I took a little time to explain problem, not the solution. Now let us see this. So, so let's create a problem here. Right click and then say new, and then already I have this Python project. I mean Python package created in my project. If you have any problem in creating any of this, just let me know. I'll help you after our session is done. Okay. Now what do we do? So right click and then say new and then say Python file, and then what is that we do? ARMSTRONG, Armstrong. Enter. So these are all very important, friends, as a part of logic building. Or if you are a beginner and if you want to start logic building sessions, like if you want to do logic building, then these are very useful for you. So now the problem is, what is our problem? Today's problem is, so what is it? So checking whether a number is Armstrong or not. This is our problem. Whether a number is what is that, friends? Armstrong, Armstrong, Armstrong. So this is one thing, okay? And always make sure you put these comments. Maybe author. Definitely we have to add all this, friends. Something like Manora. Okay. Code hygiene is very important when you are working in programming. Next, you have to take an input from keyboard n equal to input of what is it? Enter n. This n is number which is an input to check if it is Armstrong or not. Okay, and then of course you can what is that, convert it. But my suggestion is first to do one thing. So take it as a string first, and now find length of that string. Okay, what is that? Length of that string. I'll just give you how to implement this logic. If first thing you have to see how many number of digits are there in that digit. Okay, do we have 3 digits? Do we have 4 digits? Do we have 5 digits? And based on that, you have to implement your Armstrong logic. I will show you two scenarios. First thing, by checking length of that number, or what is the how many number of digits are there in that number, that is one thing. And based on that, you should implement logic. If it is three digits, you have to find sum of cubes. If it is 4 digits, you have to find sum of to the power of 4, each digit to the power of 4. You got it right. If it is 5 digits, again you have to do sum of to the power of 5. You have to do all this dynamically, friends. Okay, so let us see. This is actually a very interesting logic. If you really focus, we have a lot to learn in this logic. Okay, so now finally, what is this? You are reading n here. This is fine. And then finding length of n. Okay, to implement that finding length of n. I'll show you how to dynamically we try to length of n here. Okay, and then length equal to len of this n. Len is a built-in function. We will learn more about this kind of functions little later when we start discussing string topic or data structures topic. But for now, remember, this is easy to remember. To find length of a string or anything, we use this len, which is a built-in function. Just use it directly, and to that built-in length function, pass this n here. That is enough. That gives you length of that number. Okay, and now so you have to find this. What is that you have to do? You have to validate it. How many digits are there? Okay, there are different ways. I'll show you in future, like how to get again. So you can split it and count it number of digits, and based on that you can apply power. Okay, so that is one more thing. Okay, now length is just take this. Now finally we have to do a little validation, small validation. What is that? I'm just giving you covering two scenarios in this program, covering two scenarios. In future, you have to cover all scenarios, not just two scenarios, n scenarios. If number is n, you have to find the power of n. Like that, you have to be creating a dynamic program. I will talk about it little later. Okay. Now, covering two scenarios. So if here you can simply apply this scenario. If length equal to 3, then what is that? Now you take some temp equal to int of n. So I'm converting that number. Now this is a string, and this string I'm converting to what is that integer now. Why? Because the number has to be integer. Usually Armstrong numbers are integer numbers, not string numbers. So we are converting it to integer. By default, this is treated as a string. Whatever we read from keyboard, it would be a string. Now I converted that. Now after this, I am doing my actual process now. What is that? Let us start implementing. First thing, what you have to do is, as this is Armstrong, see the logic here. You have to find sum of cubes here. This is a very simple. Already we know how to find sum of individual digits of a number. You can just do one thing. Just take a number, sum, and set it to 0. Now here inside this, of course, you have to apply a looping also here, because here, you have 153, right? So every time you have to extract one digit from this number and find the cube of that. So for that, what you have to do, you have to start looping while until that number becomes 0, you have to keep on iterating this. You don't need any loop variable here. Maybe you use temp actually, more than this one, temp. While temp greater than 0, temp is the integer number, right? Until that becomes 0. So actually right now, assume that this number is 153. Assume I give 153 as input. Assume that you can give any number. It's not like it should be 153. If you give 153, it will check and say that if it is Armstrong or not. If it is 253, it will check and say that it is Armstrong or not. Now any number you give as an, that you have to do what you should do first. Until that number becomes 0, you should keep on iterating. And for that, this is the simple condition you apply. And now after that, you should get reminder first. Why? In this 153, first you should extract this 3. So I am taking example as 153, okay? It can be any number, if any three-digit number. If length is 3, then you should do cubes, that's all. Now, what is it? Here, first you should extract 3. After that, you should extract 5. After that, you should extract 1, one by one. To do this, we have to first to extract each digit from this number. We have to apply reminder. What is that? R equal to temp percentile 10. Then this gives what? Reminder. Now sum equal to sum plus. There are different things. We have power operator directly in Python. In maybe in Java or C we don't have. We have built-in mathematical power function, but we don't have power operator. But here we have a power operator. So what you can do, you can simply say that R to the power of, you can say LENGTH. LENGTH. This is a simple solution for you to find power of that number. Got it right? So this is a dynamic way. Understood now? So if length is 3 and you can simply say R to the power of length, that gives you what is that? Cubes. If it is 4, it gives you to the 4. Even you don't need this logic. Sorry. I think this time you can just ignore this. Just find the length, that is enough. And now you can do this directly. Right? This gives you dynamically gives you what is that whatever this length of digit, this gives you that particular logic directly without any check here. That is enough. No need of any condition check if it is a 3-digit or 4-digit, because we are trying to dynamically apply. Dynamically means we are not checking, or we are not verifying like if length equal to 3 or length equal to 4 or length equal to 5. Whatever the length that is, that will give you some of that thing, okay? Some of that, if it is 3, length is 3, we get that digit to the power of 3. If it is 4, we get to the power of 4. If it is 5, to the power of 5, something like that, okay? Now, one more small thing you have to do. What is that? Temp equal to, you have to get again. See, you need a step statement, right? In this logic, the step statement is we should get quotient. See, in the first place, if you want Each digit from this number, you should find what is that. You should get remainder here. Get remainder. That remainder is nothing but it extracts each digit. First it extracts 3, then it extracts 5, then it extracts 1. I'll show you. We'll debug and see. Just be patient to understand this logic. These are all very important core logics. Okay. Now temp equal to temp slash double slash you apply and 10. And this gives you quotient. What is this does? This gives you quotient. And this quotient acts as input for next iteration. So get quotient here. This get the quotient. We will trace and I'll trace and show you. You get a clear idea. Quotient. We are done, friends. We are done. This gives you sum of digits. Sum of that it might be cubes of digits. It might be to the power of 4. It depends on number of digits in that. You can see right. It digits number of digits in that number. This is how you have to dynamically create programs. You got it right. It now this covers all scenarios, not just two scenarios. Let us test it now. First, let us test the sum of cubes first. Later on, we'll validate Armstrong or not. Okay. Now, what is that I should print? I should print sum to get this sum of cubes here. Okay. So let us do one thing. I'll break down this program into two parts. What is this? This is getting sum of power of digits. Okay. So this is the program. Okay. Now, shall we just print sum and see here now? So let's print sum here. Print here in double quotes the sum of use a placeholder n is use a placeholder dot. Friends, are you following or am I confusing you? Just please answer in the chat box. Are you following? I'm trying to be as slow as possible. Generally, just we will finish this in just 5 to 10 minutes. But still we are discussing this because understanding logic implementation is very important. So understanding how the loop iterates, what basic things we should perform in this kind of logic, see, doing this is important. I'll trace and show you clearly so that you get a clear picture. Now, what is that? Run this now. Run Armstrong. There is a syntax error somewhere. So what is that syntax? End of line reached parsing. Which line is that? 25, line 25. Do we have any issue anywhere? Here, I think. Let me just check. Yeah, I need to put one more bracket. That's what. Okay, now we are perfectly fine, friends, with proper comments as well. If you want, this is how you can apply comments, condition, check. Okay. This is the way you have to implement that sum of to the power of that digits. That I don't know what is that power. That might be 3 digits, that might be 4, that might be 5. It depends on number of digits in that number. Let me run this now. So let us put 153. If I give 153, we should get 1 cube plus 5 cube plus 3 cube, which gives you again same number 153. Perfect. This is working perfect. Let's run it again one more time. I'll give a 4-digit number. This time we should get 1 to the power of 4, 2 to the power of 4, 3 to the power of 4, 4 to the power of 4. This time it should do that. And 1 cube plus 2 cube plus 3 cube plus 4 cube. Can you just quickly calculate and tell me what is that? 1 cube is 1. Okay. 2 cube 2 cube is 8. So you have to quickly calculate. So checking this output is important. 1 plus 8 plus 3 cube is 27 plus 4 cube, 4 16. 16 fours, how much? So sorry. 16. Sorry. This gives you to the power of 4, right? So this is 1 to the power of 4, 1, 2 to the power of 4. 2 to 4, 4 twos 8. 8 twos again you have to do to the power of 4. 8 twos how much? 16. Plus again 3 threes 9. 9 threes 27. 27 threes how much? 27 into 3 how to do plus 4 4 16. 16 4 64. 64 into again 4. Again I am wrong. Again I am wrong. So we have to find no, no, this is perfect only because we have to do to the power of 4. Just calculate this and tell me. Do we get 354? This is finding power of 4s here. 1 to the power of 4, 2 to the power of 4, 3 to the power of 4, 4 to the power of 4. Because why number of digits here is 5, 4, sorry. If it is 4-digit number, we have to find to the power of 4. If it is a 5-digit number, we have to find the power of 5. Okay. Is it 354 now? Definitely it will be 354 without any doubt actually. Got it? So,
Yes, sir.
um,
354.
yeah, definitely will be there. We'll get that because if I did to the power of 3, we got around some just around 100 or something like that. Okay, not more than that. Now, so we are getting it. You can see here, if it is 4 digits, automatically we are getting to the power of 5. Suppose let's give a 5-digit number. So suppose 1, 2, 3, 4, 5. Enter. We have 4, 4, 2, 5. Can you please find out to the power of 5, each digit to the power of 5 and all add all those powers and then, right? Uh, it will be definitely 4, 4, 2, 5. 1 to the power of 5, 2 to the power of 5, 3 to the power of 5, 4 to the power of 5, 5 to the power of 5. Just calculate this and let me know if we get 4, 4, 2, 5. Okay, here what you have to do 1 to the power of 5, which is nothing but 1 only, plus 2 to the power of 5. It should be around 32. 2 twos 4, 4 threes 4 twos 8, 8 twos 16, 16 twos 32. Okay, so it is 32. Again 3 to the power of 5. Again it is 27 up to 3 powers into 3 you should do to the power of 5. And 64 into 4. Again 64 fours I think 256, right? It should be 256 if I am not wrong. And 256 into again you have to do to the power of 4 again. Sorry, what is that? 5 into 5 into 5. You have to do this till how many times? Yeah, one more 4, sorry. And then again plus 5 into 5 into 5 into 5 into 5. You definitely will get the same answer, this one only. Can you please confirm your answer, please? Just check it and let me know. So finally, looking at this output, we are very sure this is giving us expected results here. Okay, so that's all, friends. That's all about Armstrong numbers. How to dynamically get the sum of power of that digits. Okay, so of a number, sum of power of digits of a number. So based on this length of that number, you should find that. Okay, now step 2. This is getting what is that sum of power of digits. Next one, what? Validating if it is Armstrong or not. I know Armstrong numbers within just first 1,000 numbers. Let us see Armstrong numbers, ARM, within uh, first 1 lakh numbers. 1 lakh or till 1 lakh numbers. Just let's get an idea. 1, 2, 3, 4, 5. So we can print it, of course. We can print Armstrong numbers. Here we are just checking only if one number is Armstrong or not. Okay. But next program, we'll see how to print Armstrong numbers within the range. So from 1,000 to 10,000, we have three Armstrong numbers: 1634, 1280, 9474. So these are till up to 4-digit. So 5-digit Armstrong numbers. Okay, these are enough for testing. Okay. So you do one thing, we'll create one more program to print all Armstrongs from 1 to 1 lakh or 1 to 10 lakh, something like that. Okay. So here, if it is 4 digits, this guy is doing 4 times. You can see here. If it is 5 digits, they do to the power of 5. Okay, fine. Let's do one thing. So these are Armstrongs. For testing purpose, we'll use any one of these numbers. Now finally, do the validation. What is that validation you do? Do one more thing. Copy this temp variable to copy the temp variable to one more number. Actually, temp1 equal to assign it to temp. Why should we do that? Because by the time you perform iteration, the temp becomes 0. By every time it iterates, initially it will be 153. 153 becomes 15. 15 becomes 1. And finally, 1 becomes 0. But at the end of iteration, this temp becomes 0. So to compare original value with this sum of cubes, sum of powers of that number, then we should have that actual value to compare. What is that comparison we should do? This original number you have to compare with the that sum of powers of digits of that number. So what is the validation you have to do? Validation is here. This is simple now. Now I have copied my original number. So here I did a copying original value. Okay, this is what I am doing original value. Now finally do the validation. Armstrong check I am doing here. What is that? Armstrong check. And finally, if temp1, what is that? I should equal to sem. So what is that? Now print. So here in flower braces, that number. So is Armstrong. You can simply say ARMSTRONG Armstrong. Okay. Else, what is that you need? Else print that number is not Armstrong. Here, use this. So is not ARMSTRONG. Of course, what is that I should do? I have to apply format and then so dot format and then pass that temp one first of all. Okay. Here also same thing. You can pass format because our actual value gets stored into temp1. So if it is if sum of power of that digits is equal to that number, that becomes Armstrong. So that's why what is that you should do? You should take the original number and the sum that is done by adding all the power of that digits of that number. So if both are same, your original number and the sum is same, then it is an Armstrong, else it is not an Armstrong. Now you do one thing, run this program. But before that, one important thing is make sure you copy the original number to that temporary variable. That is important. Already we put it in temp. Copy to one more temp here from temp to temp1. Temp1 has the actual value. Now run this now. So create pass 153 first. Yeah, 153 is Armstrong. Suppose I want 4 digited now. 4 digited, you can check something, any of these. Okay, you take 9474. Okay, let's try to pass it. We should get this 9474 as a Armstrong. See, it is saying 9474 is not Armstrong, but actually we should get this as Armstrong. We should get the same. Somewhere it is missing. We should find to the power of 4 right there. So in these cases, debugging comes into the picture. Let me verify where we are missing it. You can see here, power of remainder. He is just trying to do this. No problem. We'll fix this. Why I am not getting this one here? What is that I should do? So let's do this now. 1634. Otherwise, let's pass this and see. So again, let me run this. I'm not getting proper output. So what is it? 1634. 1634. Let me enter. So perfect. We are getting a perfect output. Maybe 1634 is Armstrong. It is giving it right output. Okay. Let me type the inputs then. 128208. Run this now. You can see here it's giving this as Armstrong. If it is working that for logic, for the two logics means definitely this program works for any number. So this is how testing we should do. 8208. 8208. Okay, enter. So perfect, it's working perfect. Might be the because I copied and pasted, right? Sometimes when you do blind copy, there might be some kind of special characters included in that. 9474. Let me run and see. Let me enter 9474, enter. See, this time it worked. Why it didn't it failed the earlier? Because when you try to copy and paste, there might be a possibility of having some special characters include that there. So that's why typing is the best option. You can see we have this time we have a perfect output. See here. So definitely, so we are successful in implementing this Armstrong logic, but this is a beautiful scenario. See, finally you got it right. One thing, we'll trace this, how this is working now. Suppose we'll trace from where? We'll trace from anyhow, we can start from here, no problem. Is it okay if I trace and show you for you? So how the looping is happening here, you get a clear idea how the stepwise analysis you can do here now with tracing, okay, or debugging. Right now I put a debugger with while and then I am running this in debug mode. You know, I'm taking time because I can just quickly write this code and run this and show you output and I can just jump to the next topic. But I'm taking time because only to benefit you friends. Okay. So here, what is that I should do? Enter a number. Which number shall we give? A three-digited number or four-digited number? Which one you want? Please answer in the chat box. Okay, please answer in the chat box. Three-digit or four-digit? Let's give three-digit first. Okay, so you get some quick idea. It's not like always it should be 153. Give 253. If it is 253, how many digits are there? Three digits. Then it will try to find sum of cubes of digits. Suppose if we have four digits, it will try to find sum of, it should find sum of power of four, so digit to the power of four. Okay, that is what you should do. So I give three, we get cubes, sum of cubes of digits, enter. Now debugging started. You can see here in length variable, what would be, you can see by the time the control comes to line 16, all other statements here this gets executed. So you can check quickly what would be there in this variable here. You can see the length is 3 here. Whatever you input from keyboard. Now already this PyCharm calculated length of the number here and it is showing as 3. Suppose if you give a 4-digit number from keyboard, by default it shows length as 4 here. Okay, that's the idea. Now what did we do? Again we have converted that. Here it is a string value. That string value here we have converted to integer. You can see when I put a cursor there it is showing int. When I put cursor here at length it is showing this is also int. But here if I put a cursor on n, you can see it is showing as string here. So that is the advantage with PyCharm. Just placing your cursor on those variables, you can see what is that value and type of that value without any much problem. Okay, easy, right? But you can directly observe what is the type of that without using type function. Okay, that is the idea, friends. But of course, when you are implementing a logic, sometimes you need to apply that type. That is important. Now we came to the temp. What is temp now? temp is 153. You can put your cursor here and see, sorry, 253. My input is 253, right? This time it is 253. Now, what happens now? It checks whether 253 is greater than 0. Is it true or false? True. Then it enters into the loop. We'll do step by step this thing here. This is step over. Now we came here. Now it will try to extract remainder. Remainder is what? If you divide, see, let me just show you. Let me be more clear for you. If you divide 253 with the 10, what would be the remainder divided with 10? Remainder will be, what is that? 225s. 10 25s. We get here 250, and then remainder will be, what is that? Here we should get remainder 3 because this is integer division. This performs what? Integer division. And remainder will be what? Remainder will be 3 here. You can see here, friends. Remainder is 3 here. So when you divide any number with 10 in programming, automatically it doesn't, if it is an integer division, what is that we get here? We just get blindly that whatever the value here, it just divide with uh, 250, and then finally we get remainder as 3 here. So here we don't get 25.3 because this is an integer division. It will round up there to this 25. It gets 250. So finally we get 3 here. So now if you just execute this, you can see here inside R, you have what you can see at the right itself. Remainder is what? 3. Next one. Now it will do, what is that sum of that digit? So 3 to the power of something. If number of digits are 3, it will perform 3 to the power of 3. If number of digits are 4, it will perform 3 to the power of 4. So this time it will perform 3 to the power of 3 here. Let's run this now. Now you can see here, by the time we do this is crossing here. You can see here, inside sum we have 27. See there, 3 to the power of 3 is 27. In the first iteration, so what is that? R is, we try to get 3 from 253, and then that performed 3 to the power of 3, that is 27, and next iteration. Here, what is temp now? Temp becomes 25. So when we try to divide 253 by 10, here we get remainder as 3 and quotient as 25. And this quotient, whatever we have, should be input for next iteration. So that's why. So to get quotient, what is that we should apply? We have to apply temp double slash 10. This is integer, perform integer division. Don't perform a decimal one. I mean floating point division. If you use single slash, it performs floating division. But here we need integer division, perform double slash. Then this will extract quotient, this quotient, and provide this as input for next iteration. So what we are doing, we are trying to get the quotient and we are trying to assign it to the same temp, replacing this 253 with the 25 here. You can see here. Now, what is that? Now temp becomes 25 and this is input for next iteration. Again, next iteration starts from where? It starts from 25. Now you can see control again jump back to the starting point again, because you can see now step over. Now we come here. This time this temp is not 253, but this is 225. Now 25 greater than or greater than 0. It is true. Then it enters into the, now you can see here temp has 25 in this. You can put a cursor there. Now again it will try to extract. So now this time what is that next iteration? Iteration 2. Here it is dividing 25 with 10. Just do integer division. 25, 10 divides 25 how many times? Just 2 times only. So it is not decimal integer division. It is not a decimal division. So 10 to 20. Then we get remainder here as what 5 here. You have to do in the beginning, you have to analyze your logic like this, friends, to understand, to get a bird view of that program. Now this has both outputs. If we do percentile, we get remainder. If you do slash, double slash, we get quotient. What is the remainder we get? We get 5 as remainder. You can see now, this is our n. N is 253. In the first iteration, by applying remainder, we extracted 3. In the second iteration, by applying remainder, we extracted 5. Right? From 25, we extracted 5. So that we get in this R now. So here R has what is it? 5 you can see here. Now it will perform 5 to the power of 5 cube here. Okay. 5 to the power of 3. Now execute that. Here what is that you get now? Again, what do we have in sum here? You can see sum has 152 after the in the by the second iteration it did addition of what the previous 27, what it did 27, that is what it has, plus 5 cube means 125. Finally, what is that? 5 cube, it gave 152 by now. Right? Next one. Again, if you see, it will perform, it again, it will try to get quotient of 25. Quotient of 25 is what? When you divide by 10, we get 2 here. So, temp definitely has 2 here. You can see here. Okay. Now, here, after this complete second iteration, what would be the output? Your sum will be 152 and your temp, this time it becomes what, friends? So you can see here temp finally has a 2. Following? So this is how you have to trace step by step. Even this debugging give you a clear idea if you put a cursor on each variable, what value we are getting at every iteration, in every iteration. Okay. Again, same routine story. What is that you should do? Iteration 3. Now, again, it is performing what? Iteration 3. I think I took lot of time because understanding this logic is very important, friends. Iteration 3. Again, same story. What is it? 2 greater than 0. It starts with this 2 here. Now, temp has 2. And if you see here, now it checks whether 2 greater than 0. Yes, it is true. Right? And then it goes to again reminder. Now divide again performs division here. Reminder, get reminder from 2. So now you you divide again 2 with 10. So if you divide with 10, we don't have decimal division. It performs 10 zeros 0. And here, what is that you get here? You get reminder as 2 here. See, if number is a smaller number, by default, you get that blindly as a reminder. Okay. So now you see here, we got 2. And finally, quotient becomes 0. By the end of that iteration, you can see finally quotient is 0. Once quotient is 0, you should stop that. That's all. Okay. So now, finally, in the last iteration, it will try to get a reminder. Right. You can see here, reminder is 2. And sum by default, again, it will add 2 cube. Means that 152 plus 8 around 160 you should have here in this. You can see there. So by now here itself we can conclude your original number is what, 253. Your sum is what, 160. Both are not same. This is not an Armstrong number, right? By here itself, by debugging you can understand. Okay. And finally, what is the temp? By the end, it became 0. That's why it will go to the top and check 0 greater than 0. This is false. So now once you get this 2 here from this, so once you extract 2, so find by at the end temp becomes 0. Now one last check it does. What is that? Iteration 4. So iteration 4, it checks 0 greater than 0. This is false, right? 0 is not greater than 0. It is equal to 0. So this is false. Then the execution of loop stops. So by that time, whatever that is needed, the sum and that sum of that power of that numbers digits, we have already done that. We got that. So now do the validation. Don't use temp, use temp1. If you use temp will have 0 here. See here. Why? After all these iterations, temp becomes how much here? 0. So don't compare with temp, compare with this copied, already copied value into this temp1. Okay. So we are doing that. We are validating if that sum of that powers of digits is equal to this original number, it is Armstrong. Right? This is how you have to trace, you have to understand each and every step of your logic. So if you do this for a couple of programs, automatically your logic thought process improves. I know I took a lot of time today just for one program, but this there is a lot of learning for you. So how to create that logic, phase wise, how to implement that, how to debug it, right? How to trace it both with the debugging as well as with the manual process. So these are all essential things. Whatever I am trying to do here, friends, these are needed. Trust me. This is how I have improved my programming knowledge. Understood? I know it might be little length. I mean, you need little patience here. Okay. Are you good now? So this is the idea, friends. Got it? So this is about finding what is that Armstrong number for any number of digits. This is a dynamic program. Generally, what people just teach you sum of cubes of digits, a three-digited number, they take it and just they just quickly talk about that. But this program covers all scenarios, n scenarios. Okay, so do you get it finally? So this program covers, okay, all scenarios of Armstrong. I hope you should be fine now. So we have 5 more minutes. Shall we jump to the next program, palindrome? Are you ready for this? First, I'll give one scenario. Then we will go and check this palindrome. Whenever there is a check like this, what is that? If it is Armstrong, if it is palindrome, that is a simple check, friends. But the actual core logic will be like this. Okay. So what do we do right now? Let's go and do one thing. So this covers both actually. A dynamic scenario is this next one. Palindrome program. First, understand logic always. New Python file and then palindrome. What is palindrome? Palindrome is simple, friends. Palindrome is if you take a number. So we are this time we are finding what is it? A palindrome. Palindrome check. Okay. These are all very core logics you need to master. Okay. So what is palindrome? Just for example, I'll take one number. 1, 2, 3. You reverse this. What do you get? 3, 2, 1. Both are same. Does both are same? Not same, right? So this is not a palindrome. Not palindrome. When it is palindrome, suppose you take 1 to 1, reverse it, you get 1 to 1. Then this is palindrome. Okay. So here, if you want to learn phase wise, in first phase, what is that you should do is in phase 1, you should understand how to reverse a number first. What is that you do? How to reverse a number. This is step 1. Then step 2, once you reverse that number, what is that you have to do? Validate that, validate palindrome. These are the steps you should follow. A small quick algorithm for you. Okay. So what is the validation? Validation is similar to Armstrong only. Similar to Armstrong. So one thing is, first thing, you should take an n. Here we don't need to do any we don't need to find any length or anything for palindrome because we should reverse a number. If that reversed number and your input value, if both are same, then it is palindrome. So one thing you have to do here is even while doing palindrome, first make sure you copy the original. You just make a copy of original number. Just make a copy and put it in some temp variable. Is that clear now? Because by the time you perform this iteration, at the end of that iteration, again, this becomes 0. Logic is similar to Armstrong only. So we have to do in these kind of scenarios. Okay, suppose this is Armstrong, right? So here we have to do these two operations. We should get remainder and we should get a quotient. Same thing we have to apply. This only here in palindrome, this logic changes. Other than that, these steps are same. So what is that? So this iterating this condition check will be almost same. No change in condition. Similar condition will be applied even for palindrome. And we should get reminder every time we iterate. Suppose if it is a 3 digited or 4 digited, whatever it is, every time we should extract one value from that. And then we should do the reverse, apply reverse on that digit. Again, we should get one more digit and we should apply reverse and then do the sum of that reversed number. And again, what is that do? Again, you have to get quotient as input for next iteration. So almost the approach is same as Armstrong. Only difference is what, friends? Your logic changes per palindrome. I'll just show you here. Okay. So what is that? You should first take a number n input from keyboard. Okay. If you want, you can directly assign. I'm just giving you how to dynamically read, that's all. If you want, you can just assign a value like this 1, 2, 3 and see if it is palindrome or not. By now, if you are even new to programming, looking at this number with our discussion, you can say if it is a palindrome or not, right? 123 is not a palindrome. All of you know that. Okay. Because if you reverse it, we don't get same number. Just an idea. Right. So what is that you have to do now? What is that you should do? You have to first start iterating. Maybe if you do you want to read from keyboard or already you already know that we are doing it in every program. You can do it if you want it. But right now I directly initialized it. Maybe if you want input it from keyboard saying that enter n. Okay, enter a number if it is a palindrome or not. Enter n. And then do conversion here, int of. So you can do the conversion directly here because here to reverse a number, you don't need to do you don't need to find any length here. Are you following, friends? Now after that, make a copy of this n because by the time you iterate, n becomes 0. By the time you complete iteration, this n becomes 0. So do a copy of that n and assign that n to a temporary variable. This is important. Okay. And then after that, what is that you should do? Take while loop. This time, don't say I less than or equal to 10 or I greater than or equal to 1 something. This is a different approach. What is that you should do? You have to say until that number becomes 0. Maybe you take n here until that number becomes 0. So you should say this is how you should create a condition. In such scenarios, this is how you have to create that condition that n greater than 0. Do you get this now? Now after this, next step is get the remainder. To get remainder, this is a blind tip for you. Just divide by 10. Divide by 10. Simple tip for you is divide by 10. This is an integer division. Try to understand all this, okay? Now take that number and then divide by 10. Here to get remainder, remember friends, to get reminder, you have to apply percentile. Remember that. We had discussed this in operators topic, right? Apply percentile for reminder, apply slash, single slash or double slash for quotient. If you want integer quotient, apply double slash. If you want float quotient, apply single slash. You get it right, friends? So now get reminder. So for that, apply percentile. Next logic, reverse logic, reverse. So do one thing. First take a sum. This is also doing a kind of sum only with reverse operation. Sum equal to set it to 0 first. Okay. This is per result. So if this is a resultant variable, as you are repetitively reassigning your results, so you have to set it to first initialize with 0. As it is sum, initializing 0 doesn't make any difference to the result. So we set it to 0. Sum is set to 0. Now, what is the logic for reversing sum equal to sum into 10 plus r? So as you are dividing with 0 with 10, we have to multiply with 10 here. Sorry, sum into here. Sum into 10 plus that remainder. This is the logic. You can trace this and understand how this logic is working. I taught you how to do the iteration wise tracing as well. You have to take a pen and paper, patiently put every iteration, try to iterate, I mean, trace it and see what's happening in each iteration. That gives you a clear idea. And this is the logic for reversing a number. Even if you don't understand, just you can Google it and get this logic. Not a big deal. Okay. And finally, you have to get quotient. What is the quotient? And then you have to reassign in the same variable. Don't try to put it into any other variable. N equal to n double slash 10. What is that? We are applying 10 on dividing 10 with the same n and assigning that quotient into the same, reassigning the quotient which we get here into the same n. And this acts as a step statement for next iteration. This is already discussed, so I am not taking much time to talk about it. Finally, this gives you reversing a number. If you print here, so the reverse of a number is this covers two logics. One is this is giving you the reverse of a, so some suppose n is or this one. Okay, dot format. Okay, what you do first print reverse of original number. What is original number? Put print temp here. That is first thing. Second thing, comma sum. Now, if you run this, you get a clear idea. Run this now. Here, give 1, 2, 3. Then you get 3 to 1. Okay, but this is, we didn't do Armstrong check here. This is only a program to do the reverse of a number. Even this is one logic. The second logic is Armstrong check. So what is that Armstrong check you should do now? So now we reverse this number. The second step we should do here is checking if it is a palindrome. Sorry, I think I told Armstrong, not Armstrong, palindrome check. We should do a palindrome check here. How to do the palindrome check? If don't use n. If you try to compare with the n, never ever you will get it as a palindrome. This is the mistake I did in the beginning of programming. While doing programming in the very beginning stages, I don't used to understand why it is not getting as palindrome, because I always used to compare n with some. I'm talking about some 15 years back or 20 years back scenario, not now. Okay, when I just started programming. So it's 20 years back scenario. How you think in the beginning, I'm just trying to tell you. So we should, that's why we should compare temp. Temp has actual value. So which is actually the n. So what is that you should do? Compare temp with your sum. This will perfectly gives you the output print. What is that? The dash, this you can put, assume this placeholder as a dash. Dash is what is that? Palindrome. Okay. So, and you can apply dot format in that dash, fill that number. What is that? Temp. Okay. Else, what is that? Else. Again, in that print, what is that you do? Say that that dash is not palindrome. Okay, that placeholder, I am just saying it as dash. Okay, finally we are able to perform palindrome check and do proper prints here. Let's run this program and give some one to one. This time I am giving, a palindrome directly. You can see 1 to 1 is palindrome. Okay, 1 to 1. You can just remove the da here. Da doesn't make much sense to the output. Da 1 to 3 is one palindrome. Is doesn't make, simply just make it like this. So right click and then run this. Give one more of your choice, something like 555. 555 is Armstrong, not sorry, palindrome. No doubt about it. Okay, something like this. This is how you can find palindromes. Got it, friends? Whether a number is palindrome or not. Interesting. See, I think we took a whole an hour of time to discuss just two simple logics, right? Are you good now? All of you are fine, Naveen and Hari and Jins and Pradeep. All of you are good now? Surya, I think he has office, so he just break down from that. Is this clear for all of you? Okay. So this is for today. We almost finished the core logics, understanding how loop works, everything. This is a very useful scene. All these are very useful scenarios. Tomorrow, I'll talk about for nested loops. Maybe we'll talk after doing for. I will introduce nested loops for both while and for and how to play with those nested loops. I'll talk about all that. Okay. Hari, are you good? Are you able to follow?
Yes, sir.
Okay. Okay. If you see, if you guys don't follow, you don't need to sit calm. You can ask me. Okay. Everyone I am saying, it's not just to Hari